Good afternoon. Myself, AJAY, research scholar at Shivaji University, Kolhapur, and assistant professor at KIT's Engineering College, Kolhapur, India. Under the guidance of Dr. Srinivas Patil, sir, head and the professor at the DKT's Engineering College, Engineering Institute, Ichalkanji, Kolhapur. So today I am presenting here a paper entitled as the RNN-driven integration of a spatial temporal features for the Indian Sign Language recognition and video captioning. Today's discussions, it will be a today's presentation, it includes the introduction, proposed methodology, proposed methodology, results and discussion, conclusions, and the references will be there. So let's come to the first one, the problem statement. For effective communication between normal and the deaf people faces challenges due to the unfamiliarity with the sign language recognition. To minimize this gap of a communication, technological advancement with the aid of the sign language recognition technique from the video processing plays important role. So with deep learning are the showing the significant improvement and opening a new revenue avenue, new area for the efficient ASLR develop has become possible. It will be there. Next, the objective to develop a sign language recognition system that interprets sign gestures into the into text, which enhances for the deep community using deep learning techniques will be there. So while referring the videos, there are some challenges in the sign language recognition. The first is a dynamic data. Video sequences capture the temporal evaluation of a sign, which is more complex than the static images. The second, feature extractions. We need for efficient techniques to capture both spatial and the temporal features from the videos. As well as to test our model, we require the training model. We need to train it, and it requires large data sets and intricate deep learning models for the precise recognition. It will be there. So here are with a survey, it is seen that there are some technological advances in the SLR, that is a state of art technology techniques will be there. So Shu and it's a team, they have used for the video processing, they have used a deep reinforcement learning and the video captioning. Yasin and his team, they have embedded the word embedding techniques for the context aware sense analysis will be there. Nabati and his team, they have suggested they have gone through parallel processing with LSTM networks for improved scalability. As well as Cohen and his team, they have used a CNN-based model for feature extraction in the video. It will be there. So this is our proposed methodology. This is our proposed methodology. The proposed methodology combine FFT and the residual block base CNN for video feature extractions along with side by LSTM and the GRU model for sign language interpretation. In this block diagram, the input videos with a paired the sign interpretation undergone process. The videos are then fed to CNN model to extract the local and global features from the frame. Simultaneously, test data is also tokenized for pre-processing will be there. These extracted features and the tokenized text vectors plays acts as input for the BiLSTM and the GRU model. During the testing, video frames are similarly extracted and the model predict sign language interpretation will be there. The predictions are compared with a ground truth for the evaluation will be there. So Next, video frame extractions. The proposed CNN architectures for the extraction of features from the video frame is shown in here. This model consists of four residual blocks in a parallel to the FFT features, which combines the features, combined features provide the important features in terms of a local as well as a global form it will be there. So the training model using video features and the extractions. The input to the system is the video sequence of a sign language gestures. These videos are processed to extract the features using the combination of a tabular CNN, tabular CNN, convolutional neural network, and a fast Fourier transform FFT-based hybrid model. The extracted the extracted video frames are then fed to two different types of recurrent neural network architectures, like bidirectional long-short term memory by LSTM and the get recurrent neural network unit based model. These RNN are chosen for their ability to capture the temporal deficiency in the sequential data. Along with the video frames, the corresponding words or the labels in the sign language are provided as an input to the model it will be there. The model parameters includes those of the tabular CNN, FFT-based hybrid model by LSTM, GRU, and are trained jointly using the suitable optimization algorithm such as sophisticated gradient descent algorithm. The loss function is used for training could be combination of different loss functions depending upon the specific requirement of the task will use, such as a categorical cross entropy loss for the classification will be there. Classification will be there. So here this is shows the architecture of this one. Now let's discuss on the results and discussions. The performance evaluation of a SLR is carried out with a dataset preparation and the use of a different standard CNN model for the feature extraction. The proposed model consists of a BiLSTM and the GRU is evaluated using a suitable parameters. So to get the results, firstly we need to prepare datasets. The two-phase evaluation compares datasets for the American Sign Language and the Indian Sign Language. The world level American Sign Language datasets shows 2000 plus American Sign Language words by 100 plus signers, and they include Indian Sign Language with 0.27 million frames across 4,287 videos. It covers 263 unique ISL sign language signs categorized into 15 different words. So performance analysis is carried out with using BLEU score. It will be there, and here we have preferred the key matrices like accuracy, precision, recall, F1 score, and so on. It will be there. So here it is a comparative analysis on world level American Sign Language datasets. Here the model used for the feature extractions are like which is 16, which is 19, ResNet 50, ResNet 101, Dense 121, Inception V and V3. From comparing this model, our proposed model found that 0.51 it will be a 0.51, whereas for the Indian Sign Language, it will be 0.54 BLU score, which will be there. So BLU score, we have checked it. Along with that, the different feature extraction models, performance with a different use of a different feature extraction models, our proposed model found out the F1 score of 0.99, specificity 0.98, sensitivity 99.99, and the accuracy is 99% will be there for American Sign Language. Whereas for the Indian Sign Language, accuracy we achieve is a 99.1%, sensitivity 99.2%, specificity 99.6%, and the F1 score 99.1% it will be there. So in our proposed model, we have used the combination of by GRU and the by LSTM. So comparing the single models with LSTM, GRU, and the combination of our model, So with LSTM, it will be found out that the accuracy is 0.89 or 89% for the American Sign Language, and whereas for the Indian Sign Language is 89%, it will be there. With propose our model, we have achieved the accuracy is about, it's a accuracy is about 99.5% for Indian Sign Language and 99% for American Sign Language, which shows the superior accuracy, robustness in both feature extraction and the sign language prediction. It will be there. So there are comparisons with the models like a customized design for the CNN. They have used the ISL Robita datasets. They have achieved the accuracy 87.5%. Modification in a standard model like a body sign language accuracy with 89%. The model that extract the global and the local features, which include uses the include datasets and accuracy found, they have 91%. The sign language translation networks, they have achieved 92%, whereas our proposed model for the American Sign Language, it's a 99%, and for the whereas Indian Sign Language, it is a 99.1%, it will be there. So finally, the conclusions. I want to conclude. It is the conclusion. The proposed model integrating spatial features from the residual block and the temporal features from the effective, along with the RNN architectures consisting by LSTM, GRU level, and the multi-layer, multi-head attentions, which gives the exceptional performance, achieving the 99% accuracy on both American Sign Language and Indian Sign Language. This model outperforms standard CNN pre-trained model in the feature extraction. With the BiLSTM and the GRU combination gives superior proves the superior to the other combinations such as LSTM, GRU. The BLEU score analysis further validate the model accuracy with a score of 0.51 and 0.54 on the WLASL and the INCLUDE data sets respectively. These results gives the model proficiency in the capturing intricate spatial and the temporal nuance inherent in the sign language gestures, thereby enhancing accessibility and the communication for deep and the hard of the hearing community will be there. So here are the some references I have preferred, the references, and if you have the questions, and thank you.